Hey guys, welcome to Math Mastery Elite. Today we're going to discuss a concept from limits. We're going to discuss how to solve the indeterminate form of 1 power infinity. Let us look at how to solve it. If a limit extends to a, f of x power g of x is in the form of 1 power infinity, where f of a tends to 1 and g of a tends to infinity. For this type of functions, we solve these by using logarithmic functions. We use logarithm manipulations and we apply the limit from there on. Now the method for solving these equations is e power limit extends to a f of x minus 1 multiplied by g of x. Now let us understand this concept by solving a few questions. The first question is limit extends to 0, a tan bx squared minus 3 cos square x plus 4 whole power 1 by 3x squared. And this result is equal to e power 5. Now we are required to find the value of ab. Now since they've given the answer as 5, we're going to evaluate the limit. We will get limit extends to 0, a tan bx squared minus 3 cos square x plus 4 minus 1 by 3x squared. Right, we have multiplied the f of x, which is tending to 1, minus 1 multiplied by the g of x. I hope you understood this. Now, this is in the form of 0 by 0. We will now apply the L'Hospital's rule. On applying the L'Hospital's rule, we get limit extends to 0, a secant square x bx squared multiplied by 2bx as the chain rule, plus 6 into cos x sin x divided by 6x. What is 6 cos x into sin x? It is 3 sin 2x, right? Now we will get limit extends to 0 to abx secant square bx squared plus 3 sin 2x divided by 6 into x. On solving this by using standard limits, we will get ab by 3 plus 1 is equal to 5. We will get ab is equal to 4 multiplied by 3, that is equal to 12. The answer to this problem is 12. Now let us look at the next problem. The question is limit extends to 1 tan pi by 4 plus log x whole power 1 by log x. This is in the form of 1 power infinity. Now let us look at the solution of the problem. Limit extends to 1 tan pi by 4 plus log x minus 1 divided by log x. As you've understood this is f of x minus 1 multiplied by g of x. This is in the form of 0 by 0. Now we will apply the L'Hospital's rule. We will get limit extends to 1 secant square pi by 4 plus log x multiplied by 1 by x, since we have the chain rule, divided by 1 by x. Now 1 by x and 1 by x gets cancelled. Now we will get e power secant square pi by 4, which is equal to e squared. That is the answer to the problem. Now let us look at the next question. The question is limit extends to infinity cos of theta by root x multiplied by x. Now let us look at the solution of the problem. Since limit x is tending to 0, cos theta by root x whole power x tends to cos of theta by infinity, that is equal to cos 0, and whole power infinity, that is 1 power infinity form. Now let us apply the definition of the function. Limit x tends to infinity cos theta by root x minus 1 multiplied by x. Now this will tend to limit x is tending to infinity cos of theta by root x minus 1 divided by 1 by x. And we will adjust the term theta squared like this. Now this is in the 0 by 0 form. Now we will get limit x tends to infinity cos of theta by root x minus 1 divided by theta squared by x. Since this is minus 1 by 2, as we've seen in the standard limits, we will get minus theta squared by 2 because we registered the theta squared right here. That implies we will get e power minus theta squared by 2. That is the solution of the problem, and I hope you understood how we solve the 1 power infinity problems. Thank you and see you in the next video.